So we're going to go from multiplying polynomials into factoring polynomials. And this first lesson is using the idea of finding and factoring out the greatest common factor in the polynomials, known as the GCF. So we are going to first give you a quick lesson on how to find the GCF, just in case you forgot, and then I'll teach you then how to factor from there. So the greatest common factor, the GCF of the polynomial, is the largest monomial that divides evenly into each term. And the key here is evenly. There's no remainder. So I'll kind of show you that here in this example. And the GCFs usually contain one or more variables beside the coefficient. So remember, the coefficient is the number in front of the variables. So it usually has a number of some sort in front of the variable, and then one or two variables with that. And that's the monomial, so one-termed. So to find the GCF, you have to kind of remember things about the factors. So I'm going to start with 6. And you may have done factors a little bit different the way than I write them out. So you just decide which way is best for you. Some of you write them out and you need to look through them. Some of you can just look at the 3, in this case it's a trinomial, so look at the 3 coefficients and find the greatest common factor right away. Totally up to you and how your comfort zone with factors. So 6, I always start with 1. So I think 1, 6, I'll write that down. Then I go to 2. Yes, 2 goes into 6. Okay, and then 2 times 3. And then 4, nope, not evenly. 5 doesn't divide into 6, and so the last one is 6. So there's my factors of 6. My factors of 18, and again, sorry, the coefficient here is what I'm looking at. I'm trying to find the greatest common factor of those coefficients. So my next coefficient is 18. So again, I start with 1. And then I go to 2, which is 9. Sometimes I write them over here so I don't forget. 1 was 18. 3. And then 3 and 6. I didn't leave any room to squeeze, but let's think about it. 4 is not a factor of 18, doesn't go in evenly. There's just 5, and then again I start at 6, so I know I'm done. The last one is 27. That's my last coefficient right here. So 1, I'll put 27 over here. 2, nope, it doesn't go in evenly with no remainders. 3 does, 3 and 9. And then I'm going to go through and think 6, nope. 7, nope. 8 does not, and then I know we go back to 9, so then I know I'm done. So the thing you do now is kind of look at it and say, which one are they all in common? Well, they all have ones in common, but that's not the greatest. Notice that you're not looking for the least common factor, you're looking for the greatest. 2s, nope, those 2 have 2s. We get to 3, they all have a 3. We get to 6, these 2 have a 6, and then I run out with the smallest their number of factors, so I know that 3 has to be my greatest. So my greatest common factor of my coefficient is 3. So I'll write a big 3 there. Now you have to look at the variables. So on this first term, I have an x and an x and a y, if I write it out. This one, I have 2x, so I have an x and an x. And then, of course, this last term I have only an x. So what do they have in common? It's the greatest number of variables they have in common. Well, they all have one x. This one has 2 x's. This one has 2 x's, but the last one does not, so you can't use that. This one has a y, this first term, but this second term does not, neither does third. So the only greatest common factor of the variables I have in common is just an x. So my final answer there is 3x for my greatest common factor. If you want to write down these steps, if it helps you, this is how you factor. So again, we just found the greatest common factor, and now we're going to learn how to factor with them. So number 1, determine the greatest common factor. Just what I did. Find that greatest common factor of the given terms of the polynomial. 2, this is the new stuff. The verb there is divide. So we're going to divide out, or known as factoring. So just think about, we multiplied in the last stuff. Now we're going to work on factoring, which is dividing out the greatest common factor from each term. And then we're going to write the greatest common factor first, followed by the polynomial that was left after factoring the greatest common factor in parentheses and in standard form. So that was a lot there. You're going to write the greatest common factor. So our last one was just 3x, followed by what is left after we divide the greatest common factor by each trinomial in parentheses in standard form. So remember, that's from the highest exponent to the lowest exponent. And the last one, always check. So go ahead and multiply back out and make sure you get that same. So let's get started with some examples here. I have 18. So first thing, remember, step 1, find the greatest common factor, determine it. So 18, and we just did that on the last one, so I'll make this a little faster here. We knew it was 1, 2, 3, 6, 9, and 18 is my first coefficient. My next coefficient is 12. We didn't do 12, so let's think through 12. So 1 and 12, 2 does go in, and I just go in numerical order. That way I can't miss any. So 2 times 6 is 12, so 3 does go in, 3 and 4. And I know I can quit because once I flip over and start going back up, that means there's no more factors in between because I've done the highest and the lowest. Kind of like the medium, you meet in the middle. And the last one here is 15. I haven't done that one yet today. So 1 and 15. 2 does not go into 15 evenly. 3 does. 3 times 5. And the only thing that could be in the middle there is 4, and 4 does not. So those are our final ones. They all have 1s. So that is one of my possibilities, but I don't think that's the greatest. These 2 have 2s. This one has a 3. This one has a 3. This one has 3. So they all have 3s. They don't all have 5s. They don't all have 6. Those 2 do. And this one doesn't have 15. So that is my greatest common factor. So again, you're going to look through the list and find the greatest number that they all have in common. That's why it's known as the greatest common factor. Okay. Now you need to look at the variables. So this one has 3 x's and 2 y's. The second term has 2 x's and a y. And this third term just has an x. Well, what do they have in common? This one has 1x, 1x, 1x. Since this last term, that's the only variable has, that's the only thing they all can have in common. So again, it's like our last one, our coefficient that's a common, the greatest common factor is 3, and the greatest common variable is just an x. Now, this is something new. I'm going to erase this so it's a little easier. Is now you're going to divide each term, that's that second step here, divide each term by your greatest common factor. So we're going to take and divide each of these terms by 3 x's. So we're going to take 18 divided by 3, which is 6, then x to the third and x to the first. Remember, you subtract when you're dividing, so I'd leave you with x to the second. The y, there's nothing down here, so it'd just be y to the second left. If you want to, you can think of that as y is 0. I think that's more work. I wouldn't do that. Okay, the next one here, 12 divided by 3 is 4. Then we have x to the second divided by 1x, leaves us with one little x. And then, of course, the y is just hanging out. And the last one, 15 divided by 3 is 5. And x divided by x, well, 1 minus 1 is 0, so we're out. Okay, and I actually did that third step as we did that. So we wrote the greatest common factor first, followed by the polynomial that was left in standard form. So this one had the highest exponent down to the least. Last thing I do is I just quickly check in my brain, or you can write it down. If I take 3 times 6, that's 18. X times x squared, you're going to add now, so that's x to the third. And then we just have y to the second. 3 times 4 is 12. X times x is x squared, followed by the y, because we didn't do anything with that. And 3x times 5 is 15x. So I can quickly make sure I factored out quickly because this product should be the original product. And I like to check to make sure we're correct. Next example here, again, first thing is to find the greatest common factor. So we have -4. And I'll talk about the negative here in a second. We'll just look at it as 4. Okay, so we have 4, which is 1 and 4, 2, of course, goes in, which is also 2, and 3 does not. I wouldn't write 2 2s. 1 2 is plenty. Okay, now we're going to go to 6. So we start, and we've already done this one, so we'll quickly go through it. There's 1, 2, 3, and 6. Again, some of you might not have to do this. Some of you, it really does help. And then we'll look at 10. And so 10 is 1. It does divide by 2, which is 5. I forgot the 10. Doesn't go into 3, doesn't go into 4, and then it starts going back up. So that's it. So I quickly look. They all have 1s. They all have 2s, and that's it. So 2 is my greatest common factor. Okay, so I'm going to put a 2 here. We look at x's. You can write them out. You kind of think about it. This one has 1x. This one has 2x. This one has 1. They only have 1x in common. This one has 4 y's. This one has 2 y's. And that one has 1 y. So they have 1 y in common. So there's my greatest common factor. Now I'm going to divide each term or factor out that much. It's kind of like reverse. Factoring is the exact opposite of the distributive property. So we're going to divide here. Now, I said we're going to talk about the negative. Usually, to make life easier, we factor out the negative so that that first term that we leave is positive. And at this point, it doesn't make anything easier as we just plain and simple factor. But as we go through these lessons, if we have that front coefficient after we take it out, that leading coefficient we know it as, to be a positive, it will make our lives a lot easier in lessons to come through. So we are going to divide not just by 2, we're going to divide by that -2 to get rid of that coefficient of a negative. So we're going to flip these all to negatives. So -4 divided by -2 makes 2. X divided by x means there's nothing left. X to the 4th divided by, y to the 4th divided by y leaves us y to the 3rd. Okay, remember we're dividing by negatives, so 6 divided by -2 leaves us with -3. X to the 2nd divided by an x, remember you're subtracting the exponent, which leaves you with 1x. Y to the 2nd divided by a y leaves you with 1y. Last one here, -10 divided by -2 is a +5. X divided by x leaves you with nothing. Y divided by y leaves you with nothing. So that would be the remaining polynomial that has the GCF factored out. Again, quickly check, just to double check your work. -2 times 2 is -4. X times nothing is x. Y times y to the 3rd is y to the 4th. -2 times -3 is +6. X times x is x squared. Y times y is y squared. And the last term, -2 times 5 is -10. And then we're not multiplying any other variables, so we're just going to write the xy. Quickly, Julian said it. We did it perfectly. It has the exact same. Last example today. Let's look at this one. So we have 3 as our first coefficient, which is prime, so it's just 1 and 3. 10 is 1, 2, 5, and 10, because we just did that one. And 4, we've done that one too, is 1, 2, and 4. Well, if you notice, this one, the only thing that they have in common is a 1. So technically, the greatest common factor is a 1. Okay, that doesn't going to do much for us, because if we're going to notice, there's 2 m's here, there's 1 m here, and there's no m's here. So they don't even have a variable in common. So technically, if you mathematically want to, you can factor out a 1, but that still is just going to leave you with the same thing, because if you divide each of these terms by 1, mathematically it's doing nothing. So you're still going to have 3m squared minus 10m plus 4. So you can say your greatest common factor is 1. Mathematically, that's true, but in the ideas of factoring, it really mathematically doesn't do anything. I hope this lesson helped you kind of understand, first of all, or remind you how to find the greatest common factor, and then learning how to do our first step of factoring, which is just the opposite of the distributive property.